Hello, everyone. My name is Kiersten Jowett. It's an honor to have this opportunity to speak to you today. I extend my thanks to the coordinators for organizing this event. More collaboration at the junction of geospatial sciences and the decentralized web is what I've been hoping for years. Just briefly, I'm from America, as you can hear from my accent, but I'm speaking to you from the beautiful city of Melbourne in Australia, where I've lived for 26 years. I'm in my final year of a geospatial engineering PhD here at Melbourne University. My thesis is on proof of location in distributed ledgers. Proof of location in distributed ledgers involves verifying temporal spatial data assigned to an event in a secure, tamper-resistant manner using some element of blockchain technology. My talk today is called Decentralized Proof of Location. My supervisors are Martin Tomko and Mohsen Kalantari. The structure of the talk will be a background for proof of location, briefly giving you an overview of our research, then the current state of proof of location. We'll provide what contributions open geospatial science and the decentralized geospatial web can make to science and society. And then as part of our research, we asked experts in decentralized proof of location to list the biggest challenges in the industry and areas they see could provide the most impactful future improvements. In discussing the evolution of decentralized proof of location, it's essential to recognize the significant strides made in secure, privacy-conscious location verification techniques since Waters and Felton's groundbreaking work in 2003. In 2009, diversification was introduced to proof of location with wireless certificates and Bluetooth proof of location. Around 2014 to 16, blockchain technology came to proof of location and brought privacy focus and a seminal paper by Brambilla et al. Around 2017, applications were introduced by Foam and AXA Insurance with their product called Fizzy and XYO to expand proof of location use. 2020 and 2021, security such as zero-knowledge proofs and federated learning enhanced proof of location. And more recently, we've seen an expansion of decentralization with trustless proof of location systems. Here, I'll provide a brief overview of our research. Defining proof of location. There isn't a universally recognized definition for proof of location, which complicates efforts to research and develop a reliable model due to the lack of a thoroughly validated conceptual framework. To address this, we undertook an extensive review of the literature across fields investigating how proof is established in mathematics, proof in forensic science, and proof in natural science. This deep understanding of the structure of proof was then combined with our research into how location measurements and methodologies are conceptualized. Finally, we fit this framework into the context of current implementations of decentralized proof of location as designed and developed by current leading innovators in the field. It may assist you in this talk to know that the research led to a definition for proof of location as the accepted, promoted, and used process for validating spatial temporal evidence assigned to or claimed by an event. So that defines for you what we were talking about today. The next part of our research involved 3 Delphi survey experiments with experts. The Delphi survey is a scientific survey technique that was developed by the RAND Corporation over 50 years ago, and it is still used today to forecast events. One of the benefits of it is that it removes bias from the researcher's point of view and receives input from experts in the field through 3 rounds of surveys. The reason we chose these groups is the first 2 are traditional systems that are involved in proving the location of an object at a certain time. The process used in logistics is accepted by our society as a way to prove location. There's a lot of trust that is involved when we ship something. And also, experts from land surveying participated in our survey because land survey marks are foundational to our society. So these 2 systems that prove the location of objects at certain times are run by central authorities. Decentralized proof of location, the third group of experts we are finalizing a Delphi survey with now, they're moving towards some sort of element of a consensus mechanism. So we're basing our location model that we are building on how the traditional forms of location have evolved and how they prove location, and how it's currently being used by decentralized proof of location applications and experts. The model that we're building will be used to design proof of location systems, but also to audit and assess them to see how close they are to their claims of location proof. Here we provide a few insights from our research on the current state of decentralized proof of location, its process, problems, and keys to success. Our research goes further than what we've shown here. It also investigates the technology used by decentralized proof of location experts, the limitations to market adoptions, and areas for improvement that will have the most impact, which we touch on in the last slide. Of all the items we are sharing with you today, consensus has been reached among the experts. For the process of decentralized proof of location, they identified that data collection, data sharing and verification, community engagement, information processing, decentralized authentication are some of the processes involved. Consensus was also reached on the problems of decentralized proof of location. Just a few that I'd like to share with you today are data integrity threats, network density and adoption, data quality assurance, and reputational challenges. When asked how they define success being achieved in a decentralized proof of location system, some of the keys to success they listed are that it is cyber attack resistant, that the protocol includes governance, it has traceable, auditable data, it is adaptable for various use cases, and is cost-effective. If you would like to be put on a mailing list to receive our forthcoming paper that includes complete description of our rigorous methodologies, please send me an email. My email is on the last slide. Next, I was asked by the organizers, how can the decentralized web contribute to open science and society more broadly, and specifically the geospatial sciences as aspects of society? My philosophical answer is trust. Trust is the foundation upon which all valuable things are built. Open geospatial science and the decentralized geospatial web offers science and society transparent paths to collective truths. I go a little further and say, by empowering science and society through free scrutiny of validated observations and reassessment of certainty, trust is fostered and value compounds. I'll explain that to you in English. What I'm saying here is science and society both benefit from the ability to view and scrutinize location observations that have been made and validated within the system through free and open source code, knowledge provided to them through community engagement, and free access. And they also have the opportunity to reassess how certain we can be about the location information and claims made by that system. This opportunity creates trust, and in an environment of trust, valuable things can be built, and more valuable things can be built on top of them over time. With that strong foundation, significant improvement and growth are possible. So that's a philosophical contribution that can be made to science and society. The practical answer is through some use cases. Experts have identified these as some of the main use cases: supply chain, privacy-protected location verification, vehicle tracking, which can assist in urban planning, traffic management, and public safety. And there are other use cases suggested, debated, and ranked in our study that will be published in the paper. Across all our studies of experts in the field of logistics, land surveying, and decentralized proof of location, we found the following challenges in proof of location, both in traditional location-based systems and emerging systems that contain some element that operates without a central authority. Communication refers to both the internal communication and external communication. Probably no surprise to anyone that communication is important and difficult. Location data integrity. At the core of decentralized proof of location lies the assurance of location data accuracy and reliability. Developing robust mechanisms for maintaining data integrity is paramount to building trust in decentralized proof of location systems. Unforeseen events are also critical challenges. The dynamic nature of real-world location-based scenarios demands resilience in decentralized proof of location systems. Proactive planning for unforeseen events ensures system integrity and functionality. Business and regulatory challenges are also significant for decentralized protocols. Furthermore, business strategy and operations may not be the strength of geospatial scientists or decentralized web technicians, but that is an obvious and important skill that has been identified as an obstacle by our experts. Our comprehensive Delphi studies reveal that effective communication stands out as a pivotal area for improvement in decentralized proof of location. Clear and effective exchange of information both within teams and with external stakeholders is essential for advancing decentralized proof of location technologies and applications. Experts also underscore the necessity for technological innovation, particularly in the development of efficient blockchain solutions, implementing streamlined, lightweight blockchain technologies that can support decentralized proof of location's demands without compromising performance. Device integration was also identified as an impactful improvement. Enhancing decentralized proof of location's compatibility with consumer devices to broaden its real-world applicability and user adoption would be significant. A breakthrough in technology is called for. An urgent need has been identified for a groundbreaking technological advancement to serve as a cornerstone for efficient, reliable, and successful decentralized proof of location systems. It is noteworthy, considering this workshop we are all participating in, that experts in the field strongly agree a focus on promoting open source principles can lead to significant and impactful advances. More than just sharing code, it's about mobilizing a global community to co-create the future of decentralized proof of location to transparency, inclusivity, and innovation. So, a warm salute to each of you. Those are some of the highlights that were identified for carving out an efficient and effective path for the future of decentralized proof of location. In conclusion, decentralized proof of location integrates geospatial sciences with blockchain technology for secure location verification. Our research identifies key challenges and opportunities in decentralized proof of location. Ultimately, decentralized proof of location holds the potential to enhance trust in geospatial data and drive societal advancements. Thank you for your time and attention, and a special thanks to my supervisors, committee chair, and esteemed colleagues who helped make this research possible. Thank you.